kids, welcome to today's maths class, and today we'll do direct and inverse variations. Our learning objectives are direct variation and their practical application, inverse variation and their practical application. So first is direct variation and their practical application. When two variable quantities are so related that if one increase, the other will increase. If the same definite ratio, or if one decrease, the other will decrease in same definite ratio, then the two quantities are said to be in direct variation. In direct variation, if one quantity increase in same ratio, other will increase. If one will decrease in same ratio, the other will decrease. So they are said to be in direct variation. For example, if the cost of 1 kg guavas is rupees 10, then if the quantity increase, so 2 kg 20 rupees, 3 30, 4 40, 8 80. So they are increasing in same proportion. If one quantity is increasing, other is also increasing. We say that the cost is directly proportionate to the quantity of guavas. Means if the quantity increase, the cost will also increase. We observe that ratio of any quantity in the upper row to the corresponding amount in the lower row is the same for all the values. So 1 by 10, 2 by 20, 3 by 30, 4 by 40 and 8 by 80. So the ratio will remain constant. Ratio of any two quantities in the upper row is same as the ratio of corresponding to amount in the lower rows. Like 2 by 3, 20 upon 30, 3 by 4, 30 upon 40, 1 by 4, 10 upon 40. In other words, the principle of direct variation can be put as under. When two quantities x and y vary with each other in such a manner that the ratio x upon y remain constant, we say that x and y vary directly with each other. If we take the quantity of guavas at x and cost as y, the above table can be shown as follow. So here x, that is the quantity, and y, that is the cost. So if 1 kg, then the cost is 10 rupees. So ratio 1 by 10, 2 by 20, 3 by 30, 4 by 40, 8 by 80, that is constant. So they are varying directly. Now we'll take an example. The cost of 5 kg rice is rupees 300. Find the cost of 3 kg rice. Let x be the cost of 3 kg rice. As the weight of rice increase, the cost increase. Therefore, it is the case of direct variation. So ratio of weight of rice equals to ratio of the corresponding cost. So 5 ratio 3 is proportional to 300 ratio x. So x equals to क्या हो जाएगा? एक्सट्रीम टर्म को मल्टीप्लाई करेंगे एंड मीन टर्म को. सो 5x equals to 300 into 3, x equals to 3 into 300 upon 5, that is rupees 180. So the cost of 3 kg rice will be rupees 180. Clear? Next is some important observation. Two quantities x and y vary directly if the ratio x upon y remain constant. In other words, x and y are said to vary directly if x upon y equals to k, where k is a positive constant. Next is exercise 9.1. Replace each star with the following table by a suitable number if x and y vary directly. So here 5 by 5. So this is the ratio. In direct variation, the ratio remain constant. So here 2.5, 2.5, 7.5, 7.5, 10, 10, 11, 11, 12, 12. Clear? Practice all the questions of this exercise. Next is inverse variation and their practical application. Sometime corresponding to an increase in the first quantity, there is a decrease in the second, and where there is a decrease in first quantity, there is corresponding increase in the second. For example, suppose 3 men can finish a piece of work in 15 days. Clearly, 9 men can finish in 5 days. 15 men can finish it in 3 days and 5 can finish it in 9 days. 45 men can finish it in 1 day. So, here the number of men and days required to complete that work. Number of men 3, it will take 15 days. 9, 5 days. 15, 3 days. 5, 9 days. 45, 1 day. So, the product of one quantity in the upper row and the corresponding quantity in the lower row is the same for all the values. Means 3 multiplied by 15, that is 9 into 5 equals to 15 into 3 equals to 5 into 9 equals to 45 into 1. Clear? So, the principle of inverse variation, two quantity x and y are said to be inversely with each other if there exists a relation such in type x multiplied by y, that is a constant. If a1, a2 are the value of y corresponding to value of b1, b2 of x respectively, then a1, b1, that is equals to a2, b2. Thus, a1 upon a2 and b1 upon b2 are inverse to each other. We will take an example. If 35 men can finish a piece of work in 20 days, how many days will 25 men will take to do it? Here, let 25 men can do it in x days. Clear? So, the lesser the number of men, the more will be the number of days. Clear? So, it is a case of inverse variation. First, we will check whether case of direct variation or inverse variation. Here, it is the case of inverse variation. So, the ratio of number of men equals to inverse ratio of number of days. So, ratio क्या हो जाएगा? 35 ratio 25 is proportionate to x ratio 20. So, 25 into x, that is equals to 35 into 20. So, x equals to 35 into 20 upon 25, that is equals to 28 days. So, 20 men can finish the work in 28 days. Next is solve the puzzle. 9 has laid 9 eggs in 9 days. How many eggs will 3 hens lay in 3 days? So, that is equals to 9 multiplied by 9 upon 3, that is equals to 27. Clear? Next is some important observations. Two quantities x and y vary inversely if the product x, y remain constant. In other words, x and y are said to vary indirectly if x, y equals to k, where k is a positive constant. Next, exercise 9.2. Which one of the following vary inversely as each other? Number x of a person hired to construct a wall and the time y taken to finish the job. Here we know as the number of person increase, the time will decrease. So, this is the case of inverse proportion. Clear? Practice all the questions of this exercise. Next is, let's recall. Multiple choice questions. Take the correct option. A farmer sells 40 quintal of rice for rupees 20,000. What quantity of rice would he sell in order to receive for rupees 24,000? As the quantity increase, the price will increase. So, this is a case of direct variation. So, suppose the quantity of rice is x kg. So, x equals to 24,000 multiplied by 40 upon 20,000. So, that is equals to 48 kg. So, D is the correct option here. Here we end the chapter. I hope you understand it well. Now to practice it.